Okay, so in number 15 and 12.2, they gave me a function. They said it's f of x and y is y cubed plus x times y. Okay, and then they asked me to draw this thing with cross sections at x is 0, x is 1, and x is minus 1, right? That's cool. Okay, so to figure out those cross sections, you literally just do that. So if if x is 0, that means I'm doing f of 0 and y, right? So you just plug 0 in for x. What do you get?
Y cubed.
You get y cubed. Okay, so that tells, and I'm going to try to put this together off on the side, and I'm not sure it's going to go well. So here's x, here's y, and here's z, right? So I found out that when x is 0, I'm looking at y cubed. So when is x 0? Which plane am I in?
The Z plane.
Yeah, I'm living in the yz plane. So there's a cubic happening there. You guys see that? So that's like if I forgot the x and kind of turned my vision, right, I'd see y cubed. Cool? All right, so what about at x is 1?
Y cubed plus Y.
Okay, so I'm doing f of 1 and y, so I get y cubed plus y, which is y squared plus 1 times y.
Oh.
You guys see this? Let's see, so that is a cubic with what going on? Yeah, it got kind of stretched a little bit. One way you could look at this is the cubic plus the linear function, right? So this is just kind of an exaggerated cubic, right? Roughly cubic still. It doesn't have any new intercepts because y squared plus 1 is never 0. At least not in the real numbers, right? You guys all with me? Okay, so this is a cubic plus a line, which is going to basically look like a slightly steeper cubic. So you guys see that slice is parallel to the other slice? Okay. Now what about the other one? At x is negative 1.
Minus. It's y cubed minus 1.
So I'm going to get f at negative 1 and y is y cubed minus y, right? Which is y squared minus 1 times y.
It's a little bit more exaggerated.
This one has
It has a maximum.
This one has a max and a min, right? You guys see that? So there's 3 points where this guy hits. So it's going to look like this. You guys kind of see that? And this is where drawing gets tough, right? So what's this thing look like? Well, in the middle it's a cubic, right? And if you go out in the x's, it gets steeper, right? It's still cubic, but it's getting a little steeper. And if you go back in the x's, it's going to get kind of more and more bent. You guys see that? Cool. Okay. How about in the other direction? So part B is asking me the other slices, right? So part B is asking for y is 0, y is 1, and y is negative 1. These ones are easier, actually. Why are these easier?
Because there's only one x value.
Yeah, because they're lines now, right? You guys see that? Okay, so when y is 0, this thing is,
Vanishes.
yeah, it's 0, right? So I get f of x and y is, or f of x and 0 rather, is the 0 function. That means that this cross-section is just the x-axis. You guys see that? I'm slicing in y, right? So that xz plane cross-section is just the x-axis. When y is 1, f of x and 1 is
1 plus x.
x plus 1. That's a line, right? It's got slope 1, intercept 1. So that's right here, right? And we've got slope 1. So we're going like that. And this is where drawing gets horrible, right? Okay, see that? I totally lost my picture when I put that on there. Can you guys visualize that line now? No. Sorry. So what that is, right, is if I walk along here, parallel to the x-axis, right, and I'm walking towards the positive x's, I'm just gaining at 1 unit per unit. And if I walk backwards, I'm dropping at 1 unit per unit.
So this would be a tarp shape anymore then?
Yeah, it's still kind of tarp shaped. I'm just saying that in that direction, it's linear. So you can see that line in it. You guys want a funny example of something with lines in it that you don't see? You know the cooling towers on a nuclear reactor? Those are actually made with straight girders. If you go in the math lab, there's pencils. So if you take a whole bunch of pencils and make a bundle out of them, and then twist, you'll get that shape. Right? So that part of the reason they make nuclear reactors, that cooling towers that way, is that they can build them with straight metal.
I can imagine saying, because I don't know why I was just looking at like the inside nuclear reactors and all this stuff. I didn't know what it did.
Yeah, so this thing, right, is a really curvy surface that has these lines embedded in it. Right, so like any slice I make parallel to the xz axis is going to be a line. Because this is, right, a first degree polynomial in x's and a third degree in y. So the y slices are going to be cubic and the x slices are going to be linear, right? You guys cool with that? Questions, Teals? So drawing this is hard, right? But the slices themselves are just...
I was trying to visualize it before the cross sections, which is not really possible.
Yeah, so that the tool for visualizing these things is the cross sections. So every time we start playing with a new function, the first thing we're going to do is cut it into cross sections, and then we're going to try to draw the cross sections.
It seems like a matter of like a lot of really exhausting then if you wanted to get a very complete image.
Yeah, sure, but computers do exhausting really well,
Yeah, they do.
right? So this is the technique, and then if you want a good, like if you want a really good picture, cram it in a computer and get a surface, and then you can fly around on the surface. Cool? Questions, Teals?